Hello, class. This is Mr. Walker coming to you with our notes for conditional statements. Please make sure that you got your notes from the counter and keep up with us. We got new things that we got to talk about. All right, so starting off on the rip, what are conditional statements? These are logical statements in a if-then form with two parts, a hypothesis and conclusion. So your if part, that is your hypothesis. And when we write this up in symbol notation, we usually call this P. Our then part is the conclusion. And when we write this up in symbol notation, we usually call this Q. Now, to notate a conditional statement, we use an arrow pointing from our hypothesis, aka P, to our conclusion, aka Q. So, right here are some examples. We're going to go through and either write a conditional statement or we're going to use a Venn diagram to illustrate our conditional. So, let's look at our first one. It first starts off with a rectangle has four sides. So what we want to do, we want to know what this is. A rectangle, that's a shape. Rectangle has four sides. So when we write this up, we say, if a figure is a rectangle, then it has four sides. Nice and simple. Next thing, we got glass objects are fragile. So what's the thing we're talking about? An object. What's that object made out of? Glass. And because it's an object made out of glass, it's fragile. So the way we write this up is, if an object is glass, then it's fragile. Nice and simple, no biggie. All right, next one we got. We got a Venn diagram, and this is going to illustrate what our conditional statement is. So it starts off with, if you live in Dallas, then you live in Texas. So what's the big thing that everything's in? You're a resident of Texas. You live in Texas. Now, the smaller part, the thing that leads to our then part, is that you live in Dallas. So if you live in Dallas, then you live in Texas. And those are simple things that make sense. All right. Now, next thing we got to talk about is whether or not our statements that we're rocking with are true. So what is the truth value of these statements? So truth value is the determination of whether a conditional statement is true or false. To show a conditional statement is false, you only need one counterexample. So if you have an instance where it is false at least one time, then you should know that it's not true any other time. It'll be true for some cases, not all cases. So if it's not true for all cases, you're going to call that false and give it a counterexample. So here's our quick example. It says, if it is not a weekday, then it is Saturday. Is that true? Not so much, because there are more than one days other than Saturday. It could be Sunday. So that is a counterexample that shows that this conditional statement isn't true. Okay? So it's nice and simple. We're just looking for a quick example that knocks it out. All right. Let's get into some more examples. These following ones are going to be on the right side of your paper on the I do it and the we do it part. And we're going to run through this real quick, but if you want to try it out for yourself, pause the video, then come back. All right, those of you that decide to pause the video and try it out for yourself, big ups to you. If you didn't, that's cool. You're here for the ride. Let's go ahead and get into this. All right, our first two here, we got these Venn diagrams, and we're trying to write these as conditional statements. So, just like our last time, our outside oval, that is our then part. The inside oval, that was our if part. So, what are we talking about here? We're talking about integers. Those are negative and positive numbers. We got rational numbers. These are numbers you could turn into a fraction. So if we wanted to turn this into an if-then statement, we would say, if a number is an integer, then it is a rational number. So we have one thing from the inside related to the things that are outside. That's how this is going to work. Now for the second one here, this is a topic that we're going to be covering in about a couple of months. Rotations and transformations. A rotation, that's a turn. A transformation, that's just a change to a figure in a plane. So, if a change to a figure is a rotation, then it's a transformation. Okay? Little tiny simple things like that. You'll get some more practice with it as we go through this. All right, next one we got after three strikes, the batter is out. We want to turn this into a conditional statement. So, After 3 strikes, the batter is out. We're talking about baseball. So we'll talk about if a batter, the person who's going through and getting the 3 strikes, if a batter gets 3 strikes, then they are out. So we got our if, going to our then. All right, next one we got 18-year-olds are eligible to vote. So our if is talking about people being 18. Our then, it's what they can do. They can vote. So if a person is 18 years old, then they're eligible to vote. If, followed by the then. Easy peasy, lemon squeezy. All right. On the bottom here, we got on the left of your paper, there is us identifying the hypothesis and the conclusion. On the right side, you got to show that the conditional statement is false with a counterexample. Once again, if you want to go and try it out for yourself, go ahead and pause it, spin back and try it with us after the correct or, in some case, not correct, your questions. All right, pause it up. All right, people, if you paused it and tried it out for yourself, appreciate it. Good job. Let's try out some of these. Our hypothesis is followed by the if. So in our first one, it's a little bit changed up because we don't see a then part, but I do see an if part. So our if is 2 lines intersect. That's our hypothesis. Our then is a result of the if. So for this one, it would be 4 angles are formed. Now the other two, a little bit simpler. It says if an animal is a tabby, then it's a cat. So if is the animal is a tabby, that's our hypothesis. Our conclusion is, then it's a cat. And same thing for 3, nice and simple. X minus 13 equals 9 is our if, which is our hypothesis. And our then is X equals 22. Okay, now our next set of practice problems are talking about whether or not these statements are true. Now, I'll give you a hint, these aren't. So you have to go through and give me a counter example. So, for 1, it says all odd integers are prime. If you don't remember what prime is, that means that it only can be divided by 1 and itself. So, is that true all the time? Definitely not. You got other odd numbers that can be divided other than 1 in itself, like 9, 15, 21, 33. You got a couple examples there. Next one we got. If you play a sport with a ball and a bat, then you play baseball. Is that the only possibility? Definitely not. You could also be playing softball. Last one that we got. It says, if the season is spring, then the month is March. Is that always true? Definitely not. Spring has 3 months that it could possibly be: March, April, or May. So you got other possibilities that let you know that's not always true. All right, people, make sure you get this glued up and put into your book, and make sure that you go through and stay tuned for our next videos. We're going to be talking about the converse, inverse, and contrapositive, and by conditional statements. I'll catch y'all later. Y'all have a good night.